In this video, we are going to tackle a limiting reagent problem. So limiting reagents are probably the longest, most tedious, dare I say, hardest problems that we'll do in stoichiometry. All they really are, though, is just 2 or 3 problems all put in one problem. So it's a lengthy process, but we can do it. So we are going to start these ones just like we start any other problem. We are going to write a balanced equation, which is generously already provided for us in this problem. So what we're going to do is we're going to write what we have, and I'm going to try to color coordinate, and I'm going to use red for NH3, and I'm going to use this purple color for O2. So I'm going to start with red. I have 8.00 liters of NH3. I'm going to write that right by the equation so I don't have to read through the problem a bunch of times. All my information is organized and neat down at the bottom. Oh, not are mixed with 2.00 liters of O2. So I'm going to change to purple, 2.00 liters of O2. What is the maximum number of liters of NO that can be produced at STP? So we want to find the maximum number of liters that can be produced, and we see this glorious thing at STP, so we can use our 22.4. We don't have to do the PV equals nRT. So what I'm going to do is I have 2 reactants. I need to say if I have this many liters, how many can I make of this? If I have this many liters of oxygen, how many liters can I make of NO? And based on that, whoever makes the least amount is going to be our limiting reagent. So I'm going to start with if NH3 limits. And I'm going to just look at NH3 and NO and solve for X in liters. First thing I need to do is take 8.00 liters divided by 22.4 to find out how many moles I have, and that gives me 0.357 mole. And I can make my chart right here. So 3.57 is with NH3, and there's 4 of them, is equal to X, and there happens to be 4 of NO. So I can take 0.357 times 4 divided by 4 to get 0.357 mole NO. Going back to liters, I'm going to multiply by 22.4, and 8.00 liters of NH3 is going to make 8.00 liters of NO. So I have one answer. Now I need to go back and do another problem for my second reactant. So this is if O2 limits, and I do exactly the same thing. 2.00 liters divided by 22.4 is going to equal 0.0893 mole. My mole ratio that goes with that is 5. X NO is 4. Set my chart up. 0.0893 times 4 divided by 5 is going to be equal to 0.0714 mole NO. Oops, should have switched to blue. Multiply by 22.4 to get back to liters. And if I start with 2.00 liters of O2, I get 1.60 liters of NO. I have my 2 answers, and I look at whatever one is smaller, and I can see very easily that 1.60 liters is less than 8 liters. So whatever one is smaller is going to be the limiting reagent. So as see here, O2 is limiting. Once the O2 is used up, my reaction will stop and nothing else will be made. No more NO will be made. So for the first part, when it asks, identify the limiting reagent, I did. It is O2. Second part says, calculate the volume of excess reagent that remains. So whatever is not my limiting reagent, so not this guy, I want to figure out how much, after the whole reaction is done, how much is going to be left over. So what I can do is I can say the most NO that could possibly be made from this reaction, the most, let me get rid of some of this. Whoop. Give me 1 second. The most that could possibly be made is 1.60 liters. That's the most NO that could be produced based on the limiting reagent. So if I know I'm going to make 1.60 liters, I want to solve for X as my excess reagent. So now what I did is I set up another stoichiometry problem based on the fact that that's the most NO I could ever make. So now I want to go from this one to this one. I take 1.60 divided by 22.4 and I get 0.071 mole over X, and these are both 4 over 4, 0.071 times 4 divided by 4 is 0.071 mole of NH3. Now I want to multiply by 22.4 to get that I would use, in the reaction, I would use 1.60 liters of NH3. That's how much I used up. I want to figure out how much remains. If I start with 8.00 liters and I use up 1.60 liters, I am left with 6.40 liters of NH3. So this one, O2 is the limiting. I'm going to make 1.60 liters of NO, and I'm going to have 6.40 liters remaining of my NH3. That was a limiting reagent problem from start to finish in 8 minutes and 38 seconds.